Hi guys, so today we're going to be building an oxygen concentrator. So what this device does is, this is actually a medical device used in frequently in hospitals and in the homes of patients who need enriched oxygen air to breathe because they cannot breathe well. So people who are really sick use this device with some tubes coming out of the device into their noses. Okay, so in order to build this device, we're going to be needing a couple of materials, such as some iron tubes or aluminum tubes, two of them actually, a device called PLC. This is very important for the project, because PLC is it's something like Arduino, but it's more technical. It's rather more technical and professional in terms of RAM, processing speeds, and memory. I'm sorry. Memory. Arduino's memory is actually better than PLC. I mean, the design-wise, it is better, but PLC is much more frequently used in such as factories or homes, mostly in boilers. PLC is used. Okay, so first things first, two tubes. Second, PLC. And third, we're going to be needing some tubes. Let me draw this. My drawing isn't the best, I know. We're going to be needing some tubes. And fourth, we're going to be needing valves. So we need semi-cupid valves and bicupid valves. So what these valves do is that when you place this valve, for example, right here, you can actually program this electrical valve with the PLC. So you can, let's say, you build a system like this. So we're going to be needing this. These will be our exhaust tubes. So the working principle of this material, of this product, is that we're going to be filling these aluminum tubes with a material called zeolite. So zeolite is also used in aquariums for fishes to enrich the oxygen levels. Okay. So we're going to be filling these aluminum or iron tubes with zeolite and applying slightly pressure, about like 2 to 3 bars at max, to create an oxygen output of 60 to 70%, which 21% of oxygen was our initial oxygen level in the air. So we're going to be placing a valve right here, here, and here, and here. So this is double. Okay, so 2 tubes are coming actually through this valve. So okay, so we turned on the electric motor right here. Let me draw this. I forgot to include this in the materials list. Okay, I know my drawing is the worst, but anyways. So this is air in, air coming in with pressure. So with the pressure in the air, zeolite is actually acting like a sieve. This is also called a molecular sieve. And with the right pressure, N2 is being subtracted from the air. So excess N2 is coming from out the exhaust pipes we have initially placed, and enriched oxygen air is coming from this side. And talking for the second pipe, let's say the first pipe was already used and there's excess nitrogen present in this tube. So in order to clean this tube up, we need to apply pressure from this side. So we're going to be sacrificing, let's say, some of the air that's coming to the output, let's say 1/4 of the air. We're sacrificing this enriched air for this tube in order for exhaust to work. So let me draw this again. So let's say this is a dirty tube, okay? So this is a dirty tube with high nitrogen levels. This is our tube. So this is zeolite present, so this is very filled up. Okay, so if I have to, if I have to open this up, this will actually explode. All right, so when we apply, so this is our exhaust, don't forget. When we apply the air from here, this N2 molecules are actually going with 60 to 70% oxygen enriched air, sticks with the nitrogen, goes out from the exhaust. So what we do is we sacrificed 1/4 of the air to clean this tube up. So this is the main idea of the system. So what PLC does is that PLC actually controls which valves to work in which order, in which time, in which frequency. So for the most optimal results, of course, we need to have a couple of trials, and it was a long journey. So I spent a lot of time working with the PLC as well as the tubes, but the tubes were actually the easy part. And luckily the PLC didn't work on Mac. You have to have a Windows operating system in order for the PLC to have to control the PLC actually. And that took a couple of days, but no matter what, it was a magnificent project. The results were insane. You have to see it. So let's go to the finished result and see what we did there. Okay, so these are the valves that we will be using in our project. As you can see, it works with DC 24 volts, 6.5 watts. So this is the input of the valve tube, and this is the, this is the input and this is the output of the valve. And this is to be connected to the PLC right here. So this is the PLC and this is the power generator for it. This is the adapter. This is the power adapter and this is the PLC. So as you can see, you connect the cables to the PLC in this order. This is for data transmission, and these are for the power plugs of the PLC. This is to be high voltage and this is to be low voltage, and you just have to connect the ends of the valves in this order, and then you can alter the series in the computer. You can align the order of the valves in the computer. So yeah, you're gonna need a couple of these valves. Actually, you're gonna need 5 valves for this project, and these tubes. So this was the tubes I was talking about later. These are tubes that was specifically designed not to let go of any fluid or air. You can take these off by squeezing it or by pressing right here. As you can see, it comes up very easily. You can do this by doing the same thing again. Okay. So yep, these are the valves, and this is the material I was talking about. This is called zeolite, also to be known as the molecular sieve, Zeox O2 plus. So this is so the particles are very small. They're acting as if they're fluid because they're very small. All right, so you're going to be filling these tubes with zeolite. I've had these made at factory. These are iron. I'm sorry, these are iron. The aluminum one was broken because we needed high pressure on the inside. They just broke. So this is silicon. Before you're actually completing the you're finishing with each tube, you have to apply silicon to each end in order not to let loose of any zeolite that was coming, that's inside the tube. Okay, so this is crucial because if you don't do it, when you apply air pressure with the DC motor, you're going to have a bad time because zeolite is going to spread everywhere on the floor, and it's not a cheap material, so you're going to be losing your zeolite. They're going to be losing their effect. And what else? Yeah, PS, if you touch the zeolite, if you let the zeolite touch water, it's done. The zeolite's gone. The whole packet is gone. It's the same for the water is present in air, so you have to close the cap of anything that you put the zeolite in. All right. So these are all the materials that you'll be needing. So these are the two tubes, and okay, let's connect them together and we'll see how it will end up. Alright, so this is the finished product of what you should be seeing as a blueprint. So this is just a motor that I bought from the store. This is just aluminum foil. Okay, so this is just a motor that I bought from the store. So this is a pretty cheap material that you can get nearly anywhere from 50 to 60 TL. And these are the tubes. These are aluminum to make it a bit lighter, and this is the exhaust tube to create the necessary pressure inside the whole system. This is a closed system, so we have to keep the pressure stable inside the tube. So this, I put this to create the to enable the user to handle the pressure, the rate of air that's coming out. Now this is the PLC. This is the PLC right here, and let's see. Okay, so let's turn this on. Right, so you can see the PLC's light. Where is it? Yep. There, it's working. There's actually airflow coming right from here, and you can actually change this. Come on. Alright, so this is actually not working right now. Okay, so this is the final result. As you can see, the exhaust is working perfectly fine. The only problem is the noise. It's creating a lot of noise, and this is all working fine. We're going to look at the oxygen levels of this output with an oxygen sensor. It's a very expensive material, so we're going to borrow it from somewhere else. So yeah, that's it. I'm going to draw this whole thing in the paper to make it seem a bit like ordered, I guess. Yeah. But this is the final result. It's beautifully working. It's great. Oh my god. As you can see, the oxygen levels are nearly 48%, 47.7 right now. The air has 21% initially, so we have doubled the oxygen resource in the air. Okay, so this should work as a blueprint. So these are the tubes that are filled with zeolite, and the markings that are crossed with red color are the valves. So we're going to be needing 1, 2, 3, 4, 5, 6, 7, 8 valves in total. I'm sorry, I called it wrong. I think I said 5 valves, but I missed those 3 valves at the end. So this is the input of the air, and this is the output of air that's coming out, and this is the exhaust that we will be sacrificing our 1/4 of the output air with. Okay, so the PLC should be placed at the middle, and the DC motor should be placed below the PLC. I mean, that's how I did it. It seems more ordered, and I actually cut an aluminum plate to place this all on top of 4. Okay, so what else? The valves should be connected to PLC. I'm going to be explaining how to connect these valves to PLC later on. And yeah, I think that's it. Let me see. Make sure not to have zeolite get in touch with water. I'm telling this for the second time, but that's very crucial because I lost a lot of time on it because I didn't. I mean, one of the tubes were working perfectly and the other one wasn't so well, but I mean, I couldn't guess until I changed one of the tubes and I checked the zeolite in and it was wet. So guys, it's a waste of time. It was a waste of time. So make sure the zeolite doesn't get touch with the water, and make sure your valves are intact. Make sure the pipes are stuck nicely and tightly with the valves. And so the order should be like this. So input air is coming in. One of these X's should be on, and the other one, if this A is on, this B should be on too. So let's call these AB, AB. If no 2 A's should be on at the same time. This is very important in order for the exhaust to work. So this should be open, and this should be open at the same time. All right, so we've created the necessary tension inside, the air pressure inside, and as if this is going out, also this should be on too. Also, an exhaust of air is coming out with this pressure inside. This pressure inside is transferred to here to clean this tube up to have the exhaust to work. Alright, so I'm going to be explaining how this PLC works and how you should connect the valves with the PLC. And this is the diagram. So zeolite, 2 tubes, pipes, 8 valves, PLC, and this is optional aluminum plate. And just a couple of these wires will cut you through. And make sure to have the fundamental materials such as this. I mean, it helps you a lot. And yeah, make sure to have cables, and a voltmeter is going to help you a lot through the troubleshooting process, because I mean, one of my cables weren't working well, so I just checked it with a multimeter. So make sure to have these fundamental materials at your ease. Okay, so let's go for the PLC. I'm going to be explaining how the PLC works and how to connect the bulbs.
This is the software that I used with the PLC. As you can see, the M1000s, the M's signify memory, and TMR is, I think, self-explanatory, is timer, and K is the amount of seconds for the valve to open up. Yeah, and the reset button just resets the whole process. As you can see, it's pretty easy to use.